Okay, we have a geometric series here, and we're going to try to find out if this converges or diverges. So first of all, what is a geometric series? With a geometric series, you've got this, which is what's telling us that we're going to be adding. And where do we start it? We could start it usually at 0 or 1. If we started at 0, then this thing here, which is our common ratio, and I'll explain what the common ratio is, but first I want to talk about this. I equals 0, we have to the power of n. If we have 1 here, I equals 1, then we have n minus 1. We usually do this so that this goes to 1. That's our goal, to have a power of 0 here, and therefore have our common ratio go to 1, and then we can initialize our first term with whatever number that is. So that's an a that we use for this constant. If we start at 3, we just make this go to 1 by having our first term be 1, plug that into n, that goes to 0, this entire thing becomes 1, so we initialize it here. Again, you could also do I equals 0 and just have n. And we still get our first term to be 3. So then, how do we find what r is? We found what a is. What is r? R, we take this term and divide the previous term. So in this case, it would be -4/3. And as you can see, if we multiply by -4/3 in each step, we will get our answer. And so this was kind of easy because the book itself told you this is a geometric series, so you knew to have a term here and a term here taken to some exponent. That's all a geometric series is of the form a and then r to the n, or n minus 1, in which case you tend to initialize this at I equals 1. So now that we know this, our question is this infinite series going to converge or diverge? It converges if it reaches an actual value. If it reaches a constant value after adding an infinite amount of terms, after adding for infinity, then it means it converges. So how do we find out? Well, we just have to look at what's inside here in r, because that's what's being taken to an exponent. If it's greater than 1, that means it diverges. If it's less than 1, it means it will not diverge, it will converge. So I think I said if it's greater than 1, it will diverge. If it's greater or equal to 1, it will diverge. So the only way we know for sure that this is going to converge if the absolute value is less than 1. So if this was like 3/4, we would know that this converges, because it's actually pretty intuitive. If it's -3/4 or 3/4, whatever it is, and it's taken to an exponent, you're constantly going to be adding a smaller and smaller and smaller and smaller fraction as the exponent grows larger. So you're making, remember that, we're plugging in 1, we're plugging in 2, we're plugging in 3, all the way down forever. And so this is going to get smaller and smaller and smaller and smaller and smaller. And so it does converge upon a number, because eventually you're adding, 0 pretty much. So it does converge on a number. But if it's greater, if its absolute value is greater than 1, it'll just rocket off to infinity. It's not going to reach a number. It's just going to get larger and larger the more you add to it. The more indices you move across in the direction of infinity. So in this case, because this is negative 4/3, its absolute value of negative 4/3 is 4/3. This is greater than 1. This is greater than 1, so this diverges.